you ever wondered how scientists know how old dinosaurs are? Or have you ever thought about how scientists know what the Earth was like millions or even billions of years ago? For a long time, scientists had no idea how old the Earth was. But then they began to make some critical assumptions that allowed us to give relative ages to certain types of rock formations.
Relative dating is actually really quite simple. It's the idea that you have one thing that's older or younger than another thing.
Let's say, for example, that it is the beginning of the week and you just washed your clothes. After the first day, you throw your shirt on the floor. The next day, you'll throw another dirty shirt on the floor and it will naturally be on top of the first shirt. This pattern continues throughout the week as you continuously add more dirty clothes to the pile. By the end of the week, you have many layers of dirty clothes on your floor. Which dirty shirt is the oldest? It will be the shirt on the bottom of the pile, the first shirt you threw on the floor at the beginning of the week. This is relative dating. A lot of what geologists do is based on relative dating. But how do they know they can even do that? Well, they have to make some assumptions. We know that rock layers are formed by sediment being deposited, either by wind, water, or other processes like volcanism. So what assumptions can we make? First, we need to assume that the processes we see today are the same as they have always been on the Earth. In other words, water will have always deposited sediment in the same way since the beginning of the Earth. This idea is called uniformitarianism. This is important because geologists could have no way of knowing what Earth was like 4 billion years ago without making this assumption. The second assumption geologists make is the law of superposition. To put it simply, the idea is that new sediment will be deposited on top of older rock and sediment. This is the same idea as the example of the dirty clothing earlier in the video. So the general rule is that younger rock layers are on top, and you can go back in time as you look at lower and lower layers.
So, the third assumption that geologists make is the idea of original horizontality. So, this is the idea that rock layers are deposited horizontally at first on top of one another. So, that means that when a geologist sees something like this, where there's a nice fold in the rock, then they know something's happened to that rock.
The fourth assumption is the principle of cross-cutting relations. This principle states that a fault or an igneous intrusion must be younger than the rock which has been affected. Again, this seems obvious. You can't cut a piece of paper without having paper to begin with, right? Well, this is still an important assumption that must be stated. The fifth and final assumption is the principle of faunal succession. This idea comes from having predetermined ages of certain fossils. If you find a particular kind of fossil in one layer and another kind in another layer, you can assume which rock is older or younger by the layer's fossil content. This is because we assume that a particular kind of organism would only have lived on Earth at a particular period of time. So let's wrap this up. Geologists have determined relative ages of rocks by making 5 assumptions. The first, uniformitarianism, which means that all processes in the past are the same as the present. Superposition, that older layers are on the bottom. Original horizontality, that sediment is initially deposited horizontally. Cross-cutting relations, that faults and intrusions are younger than the affected rock. And faunal succession, that there is a sequence for when organisms lived, and that sequence is seen in the rock record.
So the next time you look at a mountain, like the one behind me, White Mountain, think about what processes would have formed it. Do you see rock layers, or maybe certain types of fossils? As a geologist, it's your job to figure it out. Thanks for watching.